We all know that in data analytics, our data tells these incredible stories. But, with all that power comes a huge responsibility, security. So today, we're going to break down the absolute essentials of how to protect your data. Let's get right into it.
Really, it all boils down to this one question. Think about it. Every single piece of data you analyze, it has a source, it has a subject. Protecting it isn't just some tech problem, it's an ethical one. So the real question is, who gets the keys to the kingdom? Who gets access to all that valuable information?
Okay, so to really get how to protect our data, we first have to follow its journey. And let me tell you, it's a journey that is absolutely full of potential dangers, right from the very moment that data is created to the second it gets shared. So here we've got the whole map laid out, the entire journey of your data. It all kicks off with collection, then it moves into storage, gets processed and transformed, analyzed, and then finally it's shared. But here's the crucial thing, the thing you really got to remember. Every single handoff, every single arrow you see here is a potential weak spot. It's a security risk. And these threats, they're not just the stuff you see in the movies, with hackers and hoodies. I mean, yeah, of course, there are external attackers trying to break in, but the danger can also come from the inside. Maybe an employee who has way more access than they should, whether they mean to cause harm or not. And sometimes, honestly, the biggest threat is just a simple human mistake, a misconfiguration that leaves the front door wide open for anyone. So, with all these threats lurking at every single stage, how in the world do we build a defense that can actually hold up? Well, the answer lies in three fundamental pillars. These three pillars work together to create a really secure environment for our data. All right, pillar number one is authentication. Just think of this as the main gatekeeper, right? It's your first line of defense. Its one and only job is to make sure you are who you say you are. To put it simply, authentication is just the process of verifying someone's identity. Before any database lets anyone through the door, it asks that one super simple but incredibly critical question: who are you? And how do you prove it? Well, with stuff you're already totally familiar with. It's something you know, like a password, something you have, like a security token or that little code that pops up on your phone, or something you are, like your fingerprint or Face ID. Now, the gold standard these days is to combine these things into what we call multi-factor authentication, or MFA, and that just makes it exponentially harder for an imposter to sneak in. Okay, so you've proven your identity. You're in. But that is not the end of the story. Not even close. The next pillar is authorization. To put it another way, you're in the building, but which rooms are you actually allowed to enter? This is where authorization takes over. It's the whole process of setting up rules and permissions for users who've already been authenticated. So the question changes from who are you to the really important one, okay, what are you allowed to do? Now, can you imagine trying to manage permissions for every single user one by one? It would be an absolute nightmare, total chaos. And that's exactly why we use something called role-based access control, or RBAC for short. It just simplifies everything by bundling permissions into roles, and then you just assign those roles to people. So much easier. Here's a perfect example from a typical data team. The data analyst role, they might only have permission to read data. That's it. A data engineer, though, they need to read it, add new data, and update it. And then you've got the data admin, who has the keys to everything, full privileges. See how it creates this really clean, really manageable system of access? So in the real world, this means a data analyst can look at all the sales figures they want, but they can't change a single number. The data engineer, on the other hand, with their different set of permissions, they're the ones you can actually go in and modify that data. That right there is RBAC in action. And for all of you who actually work with this stuff directly, here's what it looks like under the hood. It's just a simple line of code, a SQL command. It assigns a specific permission, like viewing sales data, to a specific user role. It's elegant, it's efficient, and it is incredibly powerful for keeping things secure. And that brings us to our third and final pillar, encryption. The best way to think about this is like an unbreakable digital safe. It's the thing that protects your data even if, somehow, an intruder gets past those first two layers of defense. So what is encryption? It's basically the science of scrambling data. It takes normal, readable information, what we call plain text, and turns it into a secret code called ciphertext. It really is the ultimate failsafes, because even if an attacker manages to get past authentication and authorization, The data they steal will be completely unreadable. It's just useless junk without the decryption key.
And this is really important. Data needs to be protected in two different states. First, you have data at rest. That's data just sitting there on a server or in a database. Then you have data in transit, which is data that's actively moving across a network. We have to encrypt both, but we use different tools. You know that little lock icon you see in your browser? That's SSL/TLS, and it's protecting your data while it's in transit. For data that's just sitting still, we use other powerful encryption standards to lock it down nice and tight.
So there you have it, our three pillars: authentication, authorization, and encryption. But so what? Why does all this technical stuff matter so much? Well, because it's the absolute foundation for building trust and for handling data ethically. When it comes down to it, strong security does so much more than just stop hackers. It prevents those massive data breaches you hear about. It makes sure you're compliant with big regulations like GDPR and HIPAA. It lets you share insights safely and responsibly. And maybe most importantly, it protects the actual, real people behind all those numbers in your data. And that really brings us to the main point, the core takeaway of all of this. Security isn't just some problem for the IT department to solve. It is the absolute bedrock of ethical data analytics. Without it, there's no trust. It's that simple. All right, so now that you know the three pillars that make up our defense, let's flip the script for a second and think about the offense. One of the oldest, yet still one of the most effective attacks out there is called SQL Injection. So here's a question for you. Based on everything we just talked about, why do you think that specific attack is so incredibly dangerous in a data analytics system? It's definitely something to think about.